Hi, everyone, and welcome to our session on making Azure the future home for your Oracle workloads. We are excited to be here with you today. My name is Collin Bryan, and I am a product marketing manager in our operational databases team. I focus on our heterogeneous migrations, and one of those motions is Oracle to Azure. And I'm joined by Kellyn Gorman. Kellyn.
Hello, everyone. My name is Kellyn Gorman. I am a principal CSA in the Cloud Architecture and Engineering team at Microsoft.
We are excited to share additional details on how Oracle customers can run their workloads in Azure. Now, there are many various reasons why one would like to migrate their databases to Azure. There's a whole host of reasons, some that are more specific to Oracle. Data center contract expiry is one. Maybe you have a hardware refresh. You have a contract expiry happening, end of life. There are many potential reasons for migrating from your Oracle estate into Azure. Perhaps you are looking for the cloud benefits that come from running your workload in the cloud. Infrastructure on demand, you have total cost of ownership that can be streamlined through kind of using only what you need. And there's flexibility and innovation in connecting into our cloud native services. We're excited about the Oracle Azure partnership. Some of you may have heard about our recent expansion of this partnership. Our goal is to offer customers choice on where and how they run their Oracle workloads. There's three major options that I'll highlight here. You can bring your Oracle workloads to Azure Infrastructure as a Service. That includes first-party Oracle applications such as eBusiness Suite, JD Edwards, PeopleSoft, Hyperion. It also includes third-party ISV applications, as well as custom homegrown applications that you've built in that Oracle environment. The second motion that you could consider is connecting your OCI environment to your Azure environment. We have two solutions in that vein, the OCI Interconnect and the Oracle Database Service for Azure. We encourage folks to dig into the details on those two services and make sure that it is the right fit for your workload. And finally, the third option is to modernize directly into our managed database as a service offerings on Azure. You could move into a variety of tailor-built services that may be the right fit for your workload in the cloud. And that's why we encourage all to consider Microsoft Azure as the home for your Oracle workloads. At a really high level, what you get when you move from Oracle to Azure, in migrating and modernizing your workloads, you get greater flexibility, scale, and innovation with industry-leading security and compliance. With Azure VMs to cloud-native relational and non-relational databases, Azure has a home for all of your workloads. That flexibility that you gain in the cloud to ramp up and down elastically is something that we see a lot out of customers who are looking to move into the cloud with Azure. Scalable infrastructure is a major added benefit. The operational and business agility to drive innovation across our interoperability in the cloud, enabling connections to Power BI, Synapse, and other services. And finally, we do have industry-leading security, and we also have industry-leading compliance in our stack. To give a little bit more details on the Oracle Database Service for Microsoft Azure, in this setup, Microsoft Azure and Oracle customers can create solutions that use the best of both clouds. You would connect to the Oracle Cloud. They actually have a portal experience that is similar to the Azure portal experience, developed specifically for the service. You're able to access services only available on the OCI Cloud, Oracle Autonomous Database, and Oracle Exadatabase service. And you can analyze that data, import it over into Azure, push it through Power BI or Azure Synapse Analytics, and reason over that data. My one caution would be when you look at moving your workloads into this environment, be very cognizant of latency. and failover and disaster recovery when considering this service. Holistically, today, we will look at two paths to consider for moving your Oracle workloads to Azure. The first being moving to Azure Infrastructure as a Service on our Azure virtual machines. And the other part that I will dig into a little bit is our fully managed databases. And when you move to the fully managed databases, you do get that intelligent performance. You also have high availability and scalability built into the service, but you also get the time back to focus less on management and focus more on building and developing mission critical applications and workloads for your business. So as I mentioned, Azure has a destination for every workload. This, from left to right, should cover all of the workloads that you have in your Oracle data estate. We have Azure virtual machines, which is the quick lift and shift into our Azure cloud. This is applicable to all solutions on Azure. We do have, as I mentioned, the OCI Interconnect and Oracle Database Service for Azure when you want to connect to those OCI only services. And then we do have options to migrate and refactor into our relational and non-relational services. Azure Database for Postgres, which benefits from the language parity. Azure SQL, if you're looking for an enterprise-grade SQL offering. And we also have a non-relational offering in Azure Cosmos DB for the workloads that really need high scalability and throughput. And finally, for data warehouse workloads, all of those OLAP workloads that are existing in that estate, we can also look at Azure Synapse Analytics to bring them in to our data warehouse, data lakes, and create a service there to rationalize that data. Finally, I do want to mention that it's important to consider the application. Here, I've pulled out 4 separate categories. The first is a first-party Oracle application. The second is third-party ISV apps only supported by Oracle. Third is a third-party ISV app with support for Postgres or for SQL. And finally, our custom apps and data warehouses. So as you can see, all 4 categories can be rehosted into our Azure Infrastructure as a Service. The latter 2 have an opportunity for refactoring and re-architecting to modernize into our cloud native data services like Azure Database for Postgres and Azure SQL. We built this handy matrix in order to help folks understand more clearly where their options are on Azure and how they relate to Oracle workloads. And it's important to consider here that there are differences in the level of work necessary, time and effort required to move to these various services. So we called that out by indicating that there's refactor level 1 and refactor level 2 and 3. Now, when we want this conversation to happen, it's important to consider that the whole data estate can move into the Azure environment, given the choices that we make available. The Oracle workload will determine the destination. It's not something that we should force upon anyone, any particular service. The workload and the customer desire will determine the correct destination on Azure. It's perfectly viable to lift, shift, and evolve into the cloud. The first and easiest path would be to lift and shift that workload into the Azure Infrastructure as a Service environment, and then look for opportunities to innovate and attach to cloud services once you're in Azure. And finally, you might need to consider a combination where some of the workloads move to Infrastructure as a Service and other workloads move into PaaS services, and there's potentially viable solutions to engage with the OCI Interconnect or Oracle Database Service for Azure. Exadata is one that we always get questions about. Kellyn will dive more deeply into it, but I do just want to call out that yes, we do have solutions for Exadata. We do not have an Exadata in the cloud, but you can decouple from the engineered system, take individual databases and schemas within there and move them into our Azure environment. Quick customer story here. We had OBB. They are a customer who is in Austria. They were looking to build a ticket platform that was scalable for their entire business. They wanted it to scale through Europe. And in order to do so, they wanted the scale that the cloud provides. They came to us and we helped them with our partner Stream to modernize from Oracle to Azure Database for Postgres, flexible server. And this was made a little bit easier due to the language parity with PL/PG SQL. Next, I'd like to share a video where GE shared their great experience of migrating from Oracle to Azure Infrastructure as a Service, and I'll let them share in their own words.
What further post-migration benefits and value are you deriving from Azure's infrastructure?
Yeah, absolutely. So post-migration has been fun, right? Our team was not a cloud team when we first got into Azure. We had a bunch of engineers that were on-premise. We had zero cloud experience on the team, and we had to walk before we would run. Performance was probably the biggest surprise, right? Upon go live, we would see anywhere from 30 to 50% performance improvement over on-premise. And it wasn't an application or two. It was every single system that we moved into Azure was seeing that performance boost. And we're even seeing it after upgrading systems in Azure over time. The improved processing of the new CPUs and new hardware that Azure releases every year, it's just getting better as time goes on. Other benefits, I mentioned performance and stability. Automation keeps getting better across our system as our team gets more familiar with the different tools in Azure. And ultimately, we have some very happy customers that I interact with on our side, just from the speed that they can close the books, that we can lock our consolidation cycles, reporting is improved, and much more. Overall, it's been a really good experience.
We're excited about the momentum we've seen with customers moving from Oracle to Azure and the options we provide to customers. And I will pass it over to Kellyn for a deep dive into Oracle to Azure Infrastructure as a Service.
Hello, everyone. It is always interesting over here as we do Oracle on Azure. I have been here for 4 years now. And one of the interesting things as I came over is I wanted to invest more in my SQL Server technology. And I realized that Oracle often was the anchor that was holding back many Azure projects. So I started to invest in how to do this on infrastructure as a service. And what was interesting for my customers is that if we wanted to do more with that data, there was a great use case of bringing these into infrastructure as a service and bringing all of the data state. It wasn't that they wanted to just move one database or one system or one application. It was an ecosystem. So this is where I focused very heavily for most of my customers. And I was able to do more with what the data they had that they were working with yesterday. This was very powerful for a lot of my customers that they hadn't thought of previously. They may have been migrating to the cloud thinking about, well, how am I going to bring over this application, this database tier? Is there concerns about how I do things today that may impact this going to the cloud tomorrow? And we were able to assess these workloads and bring them over in a way that met their SLAs, met their RPOs and RTOs when we start talking about that recovery point objective, that recovery time objective, which is incredibly essential when you start thinking about migrating to the cloud. We right-size those workloads. And the reason that we right-size them is that we found 85% of our customers, they were over-provisioned. It's natural. If you start thinking about the way that you provision and do capacity planning on-premise, this was a critical part of our strategy as we started to talk to customers that were migrating to the cloud. They hadn't really considered this, that when they're starting to do capacity planning on-prem, that these servers had to serve them for 3 years, 5 years, sometimes 7 years. So they were sizing them up extensively. When you start to realize that that processor license that they're paying through Oracle was the majority of the cost going to the cloud, and we were able to right size the environment and then price out for their cloud licensing for Oracle from there, they ended up with 85%, either paying the same going to Azure or doing a majority of the savings towards their cloud costs. They could realign those dollars, to new cloud projects, to analytics projects, to refactoring that they hadn't thought of before. So again, as we were talking to these customers, we realized that it wasn't just one database they were bringing across. And customers, many times when we start talking about Oracle, they may be just thinking databases, and it's not. Oracle has Java, Oracle has WebLogic middleware, it has Oracle Linux. There are so many pieces to the puzzle. There may be hardware that needs to be considered or engineered systems that are part of that migration strategy that must be assessed, must be thought through, and how those are going to come over into a public cloud setting. Some of these are engineered to give better performance than anything they thought they may have gotten in the cloud, and we're here to prove them differently. So the path to the cloud, as I was describing before, is that this is kind of how it looks, is that one application or one database doesn't just come over. They're very interconnected, either through database links, co-applications, application data loads, nighttime batch processing. All of that has to come over in one big section, a big, massive move to the cloud. The network is our last bottleneck. They don't want to be separated. They're not too keen with this idea of putting one on premise, with this idea of hybrid cloud, a little challenging. I mean, we have to be honest with ourselves that no DBA wants their application and their database tier separated. No DBA wants huge distances in space and time between their actual ecosystem. So they'll try to move it together. Some of those Oracle databases absolutely have to stay on Oracle, either through first party demands on the PL SQL, development demands, their knowledge level. They may say, I just want a place to bring my Oracle database. Can I bring it to Azure? And this is where we come into play. That data that is in Oracle many times is incredibly mission critical or just very powerful when it comes to analytics. So they may want to introduce these Oracle users that were very proficient when it came to Excel to Power BI. The ribbon that they use in the application, the user interface is very, very similar. And all of a sudden, those same users that were doing analytics via Excel are doing it through Power BI, a full analytics platform. They can then bring it in and evolve it into machine learning, bring the data into a data lake, and bring in Synapse. And again, we're evolving this. That's that lift, shift, evolve. They may start to slice and dice off schemas to save money on Oracle licensing and bring it over to a PaaS solution. And that's just what you're kind of seeing in this diagram here, is that some of this data may slice off and go to a PaaS solution. Some of it will stay in Oracle, and that we have these high IO solutions in infrastructure as a service that you're going to get the same performance or better. Now, let me talk about how we actually evolve that, how we do this. And through that, we start with a migration strategy. Through this migration strategy, it's very important for us to define the goal of the project. What does the customer wish to accomplish? We go in and we assess that workload. You're going to hear us say over and over again, we do not migrate the hardware that it came from. That hardware is left behind. It may be old, it may be out of date, it may be wrong for the workload. So we're going to assess that workload, find out what needs to come over, what is it connected to? And then we're going to design an architecture that marries the best of Oracle with the best of Azure. It may not be one and the same of what you architected when you were on-prem. So it's extremely important that you look at your goals and realize that you need to change things as you go to the cloud. We will then go through a POC, a migration process, test, rinse, repeat, and then we'll deploy and we'll automate. And then we'll also talk about how to manage, how to monitor, how to automate even the monitoring and corrective actions. And corrective actions will sound very familiar, For those in the Oracle world that maybe use Oracle Enterprise Manager / Cloud Control, we utilize that quite heavily to try to automate some of this stuff. So another question that comes up often is about licensing. And licensing, you have an ability for license mobility when it comes to Oracle. You can bring over those licenses to Azure. Azure is a supported cloud for Oracle, and especially with our partnership, we have even bigger benefits because of that. Along with getting that support from Oracle for that, we also have the ability to get support for the application tier, which other clouds do not have. If you call in and say that I'm running eBusiness Suite or I have PeopleSoft running inside the Oracle Cloud, that application tier, no one even thinks about it at Oracle support. They know that we do this. They know that that's part of our partnership, and they're going to support you just the same. So that's kind of an added benefit. Understanding your licensing is extremely crucial, and that's always between you and Oracle, but we're always here to help and answer questions for you. Again, we migrate the workload, not that hardware. Again, that workload can change over time. That hardware may be out of date and may not fit the workload that you're bringing over. We have the ability to assess this workload, understand what that workload is, and then we size it out. And the way that we do that is through something called the Automatic Workload Repository. Most Oracle DBAs are quite familiar with this, but it is a performance repository that people may have been using for a very long time to do performance tuning, optimization, and troubleshooting. We actually use it for that middle word in AWR, which stands for workload. We're looking at the workload and we're assessing it. To do this, we actually grab quite a large window. We want to see the entire workload. Now, we're aware there's some averages and aggregates in there. So we have calculations that we build into worksheets that will assess that. We'll actually take into consideration those aggregates and averages and calculate over that and create peaks from it. It will grab information that it's just about 12 data points. Even though these reports are quite large, they can be anywhere from 10 to 30 pages. We're grabbing the information around the CPU usage, memory usage, I/O, and figuring out what is required to be built out inside Azure. The way that I would size this out, as you can see here, is 12 data points that we pull from here. The database name, even if it's rack, we will take a rack environment and we can size it down to a single instance and figure out, would you run comfortably in a single database? Rack is always a single solution that people kind of look at it as the solution, but it really is a solution. It is, for instance, resiliency as well as scalability. And when you talk about the Azure cloud, because we have so much HA, high availability, built in to the infrastructure in our cloud, we're not going to see rack the same way you might do it on premise, or if you would do it inside the Oracle cloud. We don't see it the same way or need it the same way. And if we built rack inside our cloud, it would be in one single availability zone. And for us, we know the availability zone goes down, rack goes down. Shared storage, all the nodes are in one AZ, doesn't work for us. So we rely heavily on DataGuard. With that scenario, our right sizing, we will take that rack environment and we will size it down to a single instance. So what you're seeing here in this sizing assessment is you are seeing 4 databases as well as 1 rack database that has 2 nodes. We take those 12 data points, and as you can see, I'm grabbing from the elapsed time for the report that we collected that workload, where you're seeing the database time, which is how busy that database was, DB CPU, which tells me about the CPU usage of the database, CPUs and core count. And core is important because that's kind of how we calculate for licensing. So I get a feeling for what kind of licenses we're looking at for this, that I'm looking for a target to meet. I'm looking to save you on that licensing charges. Memory for the server, along with the memory for the database, which is involved with SGA and PGA, which is about our sorting and hashing on our PGAs. The SGA, of course, is our buffer and everything else that is being used on here. We may also size this up extensively when we're either going to 19C or if I'm coming off Exadata. One of the first things you find out when people are tuning or bringing a database to Exadata, they shrink it all down, so it forces offloads and Exadata usage. So we're going to raise this a little bit up. Don't be surprised if you see that. And then our I/O usage. You're seeing 4 columns here. You will see us always, every time, focus on megs per second. Requests can be different sizes. So those quantities, as much as you hear about IOPS, isn't really that important to us. We're focused on megabytes per second because a meg is a meg, and that never changes, so we know what we're dealing with. This data then starts to consolidate down, and it automatically calculates and brings you something like this that says, here are your 4 databases along with your rack database that's now a single node, and this is the actual sizing in Azure for that average and aggregate workload. Plus in the red is the peaks for the CPU, the memory, as well as I/O. I/O is extremely crucial, and you'll see this workload came from an Exadata, so you're seeing some of these at 17 gigs per second. That's a lot of memory. That's a lot of I/O. So we're very focused on that. Can we handle it? Absolutely. But understanding how we do that is really important too. So I'm not going to do a right sizing demo here, but I am going to actually talk about how we've done this and how to select these. This is extremely crucial as you're deciding what is the right sweet spot for Oracle. Azure is an enterprise level cloud. It covers a lot of workloads. Oracle is a specific type of workload, and knowing what are the right places for Oracle workloads to run is the way to success. So you will see us focus on E-series, M-series VMs. I know those A's and B's look really, really attractive at the cost, but they're not the right place for Oracle. Oracle, when you look at like EDS v5s, these were specifically made to run Oracle workloads. They have higher I/O limits on them because your VM decides what your actual limits are on I/O. So we're going to be looking at those. There are limits on those that go up to 4,000, 5,000 megs per second for attached disk. We'll also talk about when you switch from attached disk to network storage, which gives you even higher I/O. And that's when you get into that, 5,000, 12,000, 30,000 megs per second. We're looking at network attached storage. M series gives us higher memory, but we will only use it many times with network attached storage because they have lower attached storage, actual megs per second throughput. Doesn't work as well for us. So we're always looking at that higher I/O. D series you might use for development load workloads, things like that. QA, you're just testing stuff. But you'll see these ones for ABs, L, F, H's. They may look really, really cool and have a lot of memory and high Ice Lake chips on them, but they're not right for Oracle. Use the right VMs for the right workload. Let's talk a little bit about storage. So premium SSD is where we sit. You're going to hear, standard SSD, and you're going to hear, we'll talk a little bit about UltraDisk here as well. We're going to talk about premium SSD first. The P10s are really great for OS level disk. Oracle runs the OS a little hot, so see that circle around P30s through P50s. Now, you may be wondering why I'm going there and not automatically going to the P60s, P70s, P80s that have higher megs per second. There is something called host-level caching. Host-level read-only, and read-only, not read-write, is fantastic for data files. We don't do write because we want those data files to write through. But notice the cache limit and the actual megs per second. This is free to you. Bursting you have to pay for. Bursting is inconsistent. Not really something that DBAs like. But the ability to get on the P30s 500 megs per second instead of 200 megs per second just by turning something on at the VM level and then the disk, I'll take it any day. Next is 750 megs per second for the P40 and the P50. Now the P50, it goes for 4,096 gigs. 4,095 is my limit on there. So I just leave that last gig unallocated and I get 750 megs per second and it runs incredibly well. Now keep that in mind. As we look at the P60, P70, P80, we have to start thinking about what we get maybe in bursting, which has to be available and may not be there when you need it, versus what you're getting on the throughput per disk without any bursting. If I have the choice of getting 750 megs per second on a smaller disk and pay less and get what I need, I'm probably going to strike P40s and P50s and get something better for me. Read-only caching, host-level caching is our win here and why we have a tendency to love those disks more than any others. Next is my decision matrix. And with storage, it's really important to kind of know when do you flip over next level of storage. We talked about premium SSD, but let's talk about UltraDisk. And UltraDisk we're going to go into here, but keep in mind, UltraDisk, it's fast disk, absolutely. You pay for it by the throughput that you decide, the size that you decide, and even your allocation and how much block changes you make. That can be very expensive for a large database like Oracle. So I recommend using it for redo logs. Redo logs are really awesome for it because redo logs are quite small. They need fast read and write, great throughput. And let's say I've mirrored my redo logs. Well, those are going to have a lot of hits, writes on them, reads from them. I mean, I can put those on 2 small Ultra disks, pay little money for it, and get great throughput, and they're not in the same place as my data files. Awesome opportunity for it. So we talk about Ultra disks. We're probably going to talk about it with redo logs, and that's about it. Next is going to network storage, and that's those next 3 to the right, which is Azure NetApp Files, which is a native solution from Azure. There's a lot of great opportunities that are coming up with this with the next release. Watch it close because I love this. We get about 4,500 megs per second with it right now. For one of my use cases that I can talk about a little bit, we're on our 14th Exadata migration for them, and I do very little decoupling. They followed my framework very quickly. The application tiers were on Exalogic, a lot of Oracle apps that needed clear, easy cloning, and they were able to do this on ANF, and with the capacity pools, do clones one after another, and it made it a lot easier than doing like fast clone through Oracle, which we all have to admit isn't very fast. So it's nice to be able to do that, but they can spin up as many databases as they want, read and write. They still have great performance on production, and they were able to get better performance than they did from their Exadatas. So this is a big deal with this. Silk is my next one. Silk is a third-party storage solution, and they're using Kubernetes underneath the covers. It uses D and then L series and uses the ephemeral disk on it to be able to get very, very fast performance. This looks just like a storage layer, just like any other storage layer. We love using it with ASM, connecting it to our EDSV5 series, and we can get up to 15,000 megs per second that we've done with testing with some of our great Oracle customers. This is phenomenal performance where customers never thought they could do this with Oracle on Azure. And then FlashGrid. If you need to have rack inside a non-Oracle cloud, this is the way to do it. FlashGrid gives incredible support for their customers. I don't want anyone to go without support, and Oracle's not very keen on supporting people if they don't use rack inside Oracle Cloud. This is the way to do it and get first-rate support that is far beyond anything I've ever seen from Oracle. They take care of their customers, and they will support both the Azure tier as well as the Oracle tier. So you don't have to worry about people pointing fingers. They're the go-between. They're the one throat to choke, which is awesome. So distribution of data across storage. This is kind of that next step. We've gone through the physical. Now let's go to the logical placement of those files and how we do this. We do kind of a level 1, and it keeps going past 5, but I talk about 5 here. What you're seeing here is how we do this. You may have a small database that you can just throw in one disk and it runs fine. You may do your backups, copy them over off of the actual availability zone onto another region, and you're covered. You've got your DR, you're good to go. We have other customers that may say, you know what, I need to have striped disks. I need to have my backups brought over to faster storage because my RMAN runs a little bit slower, and I'm going to bring my archive logs and put them out somewhere else. I may use ASM to help me with my performance. Automatic storage management, for those of you that may not use it, most do inside Oracle, and it's a great benefit we find, especially for anything that writes and reads from temp a lot. And then we have Azure NetApp Files. As we were talking about, this gives you a capacity pool that you can share, create snapshots, and replicate a database in just a matter of minutes. These are extremely important to customers in finding the right solution, what you need depending on your SLAs, what you need for high availability, failover, DR. All of these go into play when we're figuring out the architecture and the storage that is best choice for your customers as you're going forward. The most important thing is to realize that we're architecting for the cloud. Do we need Exadata? Exadata is really awesome. It's engineered to run Oracle optimally. What we find, though, is that most of them are bought for 1, maybe 2 databases. They're the ones that are using the engineered features. The rest of the databases are just kind of consolidated on there. So for us, when we bring over these databases, we're absolutely looking at the workload, and we find that the rest of them can lift and shift very easily, and they may be paying for a lot that they don't need. I have had customers that have saved anywhere from literally $30 million for 2 Exadatas because they were over provisioned. There's a lot of money behind that box. We're just talking about Oracle licensing. We're not even talking about the 25% service contract every year. We're not even talking about replacing that Exadata hardware. It's not exactly the most green solution either. Being able to run in the cloud means that you can scale up when you need to. You can get more performance when you need. You can get more storage and then change things and move them around. As new hardware comes up, you can change over to new VM series. This is really beneficial to our customers. And one of the reasons that we have been migrating Exadatas left and right into the Azure cloud. Now with this, we're also changing the idea of how you architect. We're talking about rack being instance resiliency and scalability. We found that only 7 customers in the thousands of workloads that I've assessed over the years needed rack. They were using it for scaling. Instance resiliency changes when you're architecting for the cloud. So we rely a lot on DataGuard, which is very similar to always on availability groups for SQL Server and Azure SQL. It marries well with the Azure cloud. So we architect for this. We use a lot of fast start failover. We use the DG broker and the observer to be able to automate a lot of that. Most of our connections actually know what database is up and running through the observers. We architect for our solutions at customers that are going from on-prem into the cloud. They will have a DataGuard secondary, and they're able to use Golden Gate to keep it in sync until they're ready to fail over. We may use FarSync to go from one region to another region on the other side of the planet to make sure that that high availability, depending on their configuration for their standbys, no matter if they're looking at, this is my HA secondary in a different availability zone versus a standby that's sitting on the other side of the planet that's set for maximum protection. Those are extremely crucial to us that we architect for the cloud, not for how they've always run their workloads. So as we were talking about, there's a lot of options here. We depend heavily on FSFO, DataGuard for our customers that are using always on availability group, or I'm sorry, try this again. If we talk about our customers that are using automatic failover with Oracle, we really like some of these options with DBMS rolling. They may be using Active DataGuard, and for those folks that are going, I really like being able to do online patching and upgrading. This is there. Most folks may not be aware of it. So having this capability is really nice. Having availability sets and replication of that, doing, snapshots through Azure Backup is really nice too. And you can still do point-in-time recoveries with that. You're still using RMAN for your archive logs. And again, even if you put it, let's say, on UltraDisk, and you'd be able to use those logs to then do a point-in-time recovery with it. So what are tips for success? Let's start talking about that network being our last bottleneck. We like those VMs that have accelerated networking. We like ExpressRep. Gives you quick connectivity between your on-prem and the cloud. The site-to-site VPN gateway. This is another way to get very fast connectivity as well as uptimes. And then for multi-tier Oracle environments, it's important for us to use proximity placement groups. That's letting Azure know that this application tier and this database tier, or maybe this other database that has DB links between it, are all acknowledged as being connected, and Azure knows about that. So it's one more step of making sure that you get really good performance from Azure. We also like to simulate PaaS for infrastructure as a service, and you may not have been aware that we could do this. Oracle Enterprise Manager is the way that we do this, also known as Cloud Control. No one's really adopted that name, but it's not a big deal. We know that. Still always OEM to us. But if you were to see a lot of the automation that's built into OCI, you would be able to follow those paths back into the hosts that do this, and you would see EMAAS, and that is Enterprise Manager as a Service. We're just using Enterprise Manager inside Azure to give us that automation. We use automated Linux patching that we have available to us with OEM. We can automate the database patching. We can put in corrective actions and use metric extensions to monitor things that are important to us, do those corrective actions, and even use your same scripts that you may be doing specialized things inside your databases and automate it and then just notify you of it afterwards. But it leaves you freed up to do the things you really want to do, not the things that are kind of tedious and that you think you have to do. So with this, we are absolutely taking your on-premise templates, which you can do within Enterprise Manager and export those. You would put an Enterprise Manager in the cloud. Don't try to run it on-prem. It's very chatty, and you don't want to pay for that egress and ingress back and forth. So you put it into the cloud, you would run it with the cloud and lifecycle management packs, and you could then do your patching. You could then do those metric extensions and automate everything. There's a lot of stuff that's out there. And with the renewed interest at Oracle and Enterprise Manager, that means there's always more that's going to be capable of doing and coming down the road. And modernization is the future. A lot of customers are still using like OBIE, the Oracle Business Intelligence. And we find that they may have had old Tableau reports that nobody really knew how to upgrade or work with. For our Oracle customers that are incredibly skilled with like Excel and Tableau and OBIE, we bring in Power BI and they just immediately embrace it and they go forward with it. The idea that you can connect this data and do more with it with Synapse is phenomenal. There are research studies that show just getting more value from 10% of the data that resides in these Oracle databases could result in millions of dollars of revenue. This is one way to do that. Especially with those Hyperion and S-based customers, we know that they are phenomenal with Excel. So giving them Power BI is just a natural fit. We also have that ability once we get them into Azure and Oracle is running and they see that we run these so well that they may start looking at schemas. We find the idea of slicing off schemas and refactoring those to maybe an open source platform such as PostgreSQL or going to Azure SQL Pass. This again eliminates more of your licensing costs, allows you to go past solution, and customers are able to evolve and do more. This is kind of the way that we've been doing this for years now, and it saves customers money and they find out that they're doing a lot more than they ever thought they did before. And this kind of makes Azure the home for your Oracle workloads. And
Thanks
with
so
that,
much.
Collin,
Sorry.
all yours.
Yes, thank you, Kellyn. We are very excited about the opportunities made available to current Oracle customers. We have an extended range of customer choices. We are at a differentiated position thanks to our partnership with Oracle, and we are excited and ready to work with folks. In order to start a conversation, you can work with Microsoft Sales to be nominated or find an offer through the Azure Marketplace. The first step, once you enter that path, is to, in the IaaS realm, provide inventory of systems to move and run the AWR reports. That's kind of what we start with in Kellyn's realm. For the PaaS side, we'd look at performing a migration assessment and determining the target destination on Azure. We do have migration guides that are available on our docs page, and we encourage folks to go there. And finally, I just wrap it up with, again, you can migrate and modernize your Oracle workloads to Azure for greater flexibility, scale, and innovation with industry-leading security and compliance. We thank you for being here with us, and we look forward to hearing from you.